Alright, today we are doing the spring algebra PMA review. Tomorrow we have our PMA, which is like a district assessment. We took one back in about November, and now we got to take our spring one. Alright, so I'm not going to try to take up 50, 60 minutes and do every single question. Okay, that's up to you. Make sure you're ready for tomorrow. I'm just going to do a couple of each. I'm going to try to keep it within 15 minutes. We'll see how we do. All right, so looking at number one, simplify the following expression. We're going back to right when we came back from Christmas break. Combining like terms, we were multiplying, dividing, adding, and subtracting. Adding is easy, just combine like terms. We see here, let me change colors actually. Let's be blue today. All right, we just look for like terms, this one and this one. We're adding together. 2x cubed plus 7x cubed is 9x cubed. All right, that's done and that's done. Now, because we like to go in exponential order, remember go in order, is 5x squared. Does that have anything to combine with? Yes, it does. This negative 8x squared. When you combine that, you get negative 3x squared. That's done and that's done. Now we have positive 4 plus negative 6. Positive 4 plus negative 6, or 4 minus 6 is negative 2. Done and done. Is there anything else to combine with? Nope. So that is our final answer. Simple, simple stuff. Okay? That was easy. Just combine like terms when it's addition. Looking at number 2, subtraction. Remember, I said it a lot of times. Excuse me. I said it a lot of times. When in subtraction, we can turn it into addition. We saw how easy addition just was up here. We can turn it into addition. How do we do that? Send this negative over here and multiply all these, flip the sign, multiply them all by the negative. If that seems too confusing, honestly, you can just go negative 6x to the fourth minus negative x to the fourth. But that might sound confusing. So what I like to do is turn it into addition. The first polynomial stays the same. We just flip the sign for the second one. So that becomes negative 7x cubed plus x to the fourth plus 3x. So that's all new. And now we combine it with 8x minus 6x to the fourth plus 2x cubed. Notice the first one doesn't change. So let's go in exponential order. 6x to the fourth plus x to the fourth is a negative 5x to the fourth. All right, so that's done, and that's done. Next, we have to the third. So we have 2x to the third plus negative 7x to the third. 2 minus 7 is, again, negative 5x cubed. All right, that's done, and that's done. We're not looking at this one anymore. Lastly, is just 8x plus 3x, which is 11x. And we are done. See how easy it was once we turned it into addition. Remember, only the second one, the sign flips. All right, moving on. Like I said, go back if you need to. I'm not trying to take up too much of your time. Sorry, y'all got another visitor. All right, I shouldn't have any more interruptions, but we're moving on. Number 3, we need to find the product. Find the product means multiplication. Remember, when you're multiplying polynomials, multiply everything by everything. Don't just do this times this and this times that and we're done. No, you're doing this times that and this times that, then this times that and this times that. So following that, 4x times 5x is 20x squared. Remember, an x times x is x squared. This should be basic stuff, okay? Then we have 4x times 4, right here, 4x times 4, and that is plus 16x. All right, so we're done with the 4x. Now we need to look at that negative 5. Negative 5 times 5x is negative 25x, excuse me. And then negative 5 times positive 4 is a negative 20. Are we done? This is where I would always ask, are we done? And you would say no, because we can combine these two because they are like terms. 20x squared, that has nothing to combine with, it's part of the answer. Positive 16x minus 25x is a negative 9x. and then the negative 20 has nothing to combine with. So that is the simplest form, okay? Finding the product is really easy. I'm not going to do number 4, but I'm going to show you. Remember, it has an extra one. Don't freak out. This times this, and that, then here, here, and here. And that's it. All right? So you would get 6 terms here, and then you would combine them if you can. All right? Down here on number 5, again, I don't want to take up too much of your time. Y'all were pretty good at finding the product here. There's 3 terms here and 3 terms here. So how many terms should you get down here? 9. That's how you know what you're doing. All right? 1, 2, 3, 4, 5, 6, 7, 8, 9. Boom. If you do it correctly, you get 9 terms, and then just see if you can combine them. All right, moving on. We're going to divide this one. We're going to divide using synthetic division. All right, good times. Most of y'all loved synthetic division. Some of y'all even did your project last week on synthetic division. All right. First step, create an L. Second step, take this number, put the opposite outside here. All right, then we write our coefficients out. This coefficient is a 1. This is a 16, this is a 61, and then a negative 34. All right, then we drop the first one down. We always drop that first one down. Then we just do some math. Negative 8 times 1 is negative 8. Then we combine those two numbers to see what our next number is to mess with. 16 minus 8 is a positive 8. Then we keep going. Negative 8 times 8 is negative 64. 61 plus negative 64 is a negative 3. All right. Then we have negative 8 times negative 3, and we get a positive 24. All right. With this positive 24, we combine it, and we get negative 10. Then we fill in the answer 1 power down from the highest exponent. So instead of starting with x3, our answer is going to start with x squared. So 1x squared plus 8x minus 3. That negative 10, there's nowhere to put it, so that means that negative 10 is our remainder. Minus 10 over our remainder, which is what we divided it by, x plus 8. And we're done. That's it. All right? Synthetic should be easy, easy stuff, okay? Rewind, again, rewind if you need to. I'm not trying to take up too much of your time, but I also don't want to rush through it, so if you need to go back, do it. All right, moving on. We don't need to divide again, so we'll skip 7 and 8. We're going to go to 9, 10, and 11, because for some reason we still don't get difference of squares, sum of cubes, all that stuff, okay? So looking at number 9, it is a difference of squares. The reason we know this is because a squared is a perfect square and 81 is a perfect square. That means they both can be square rooted. The square root of a squared is just a. Remember, like I said, the square root of x squared is just x, because x times x is x squared. Okay? There's no trick to that. You just got to trust me on that. When we factor and we see a squared minus 81, it's a difference of 2 perfect squares. If it's a difference of 2 perfect squares, the answer is simple. It's just a minus 9, that's an a, sorry, and a plus 9. One is plus, one is minus. Difference of squares is really easy. The square root of a squared is a. The square root of 81 is 9. One is minus, one is plus, and that's it. All right. Number 10 is a sum of cubes. All right. Again, there's a formula for sum of cubes, but first we need to take out the GCF. So 2 and then a cubed plus 8. The reason we know these are perfect cubes is because the cube root of a cubed is just a. The cube root of 8 is 2. So we just fill it in from the formula. All right, so 2a plus 2, all right, times a squared minus 2a plus 4, all right? And remember, that was the one that was plus, minus, plus, because there's a plus here, so it starts with a plus. Plus, minus, plus. Talked about that before, all right? Moving on, we can skip number 11. We can skip number 12 as well. We know how to factor. So looking at number 13, it says select the appropriate graph attributes for the function given. This is where you'll just put it in your calculator. And we notice it goes from -2, all right, all the way, these are supposed to be negative, it was a typo. Once you put it in the calculator, you see the domain goes from -2 all the way to infinity. And then the range is -infinity up to 0. The x-intercept, again, we do menu 5, 1 to trace. We see the x-intercept is -2, 0, and the y-intercept is 0, -1.41. Again, that's putting it in the calculator. Scratch pack graph, menu 3, 1, type in the equation, and then just menu 5, 1. All right? Same thing with number 14, going up to 15. Select all the transformations for this function. We have the square root of x plus 8 minus 1. All right? We know inside something tells a lie. So when it has plus 8, we're not going right 8, but we're actually going left 8. Remember that. The only thing after that is outside tells the truth, minus 1 means down 1. Look at that, we're already done. So inside tells a lie. X plus 8, you usually think, oh, we're going to the right, but we won't go to the right because it tells a lie, so we'll actually go left 8. All right? Transformation should be easy, easy. Here we go again. The cube root of -x plus 2, and then on the outside, plus 1. The first one, we see this negative inside. It's next to an x. So you would think it's reflection over x-axis, but because it's inside, it tells a lie. So a negative on the inside right next to the x, it is actually reflected over the y-axis. All right, then we have the negative x plus 2, so instead of actually going right 2, we're going to go left 2, and then up 1, and we're done. Transformations are easy, easy. Number 17, let's solve this. We are solving square roots, and then we'll do 18, which is cube root. First step, divide by 7, because we got to get this radical by itself. Remember, this is a radical. So get it by itself, divide by 7, divide by 7. So we have 9 equals the square root of 16x plus 1. All right, what do we need to do next? We need to get rid of that radical. So we're going to square both sides. 9 squared is 81 equals, this cancels with that. Remember, I used to say that all the time. Trust me on that. The square root of something squared, it just cancels out. All right, so we're left with 16x plus 1. That's what we want. Now we just solve for x. Minus 1, 80 equals 16x. Divide by 16, divide by 16. X equals 80 divided by 16 is 5. So our answer is D. All right. Should be easy to solve if you know what you're doing. Number 18, notice it is a cube root this time. So when we get there, we're going to cube it. Don't get mixed up in square. First step, we need to subtract 8, subtract 8. All right, we're left with the cube root. Remember, it's a cube root, a little 3 there. 135 minus 2x equals 13 minus 8 is 5. Now the only thing in the way is that cube root. So we're going to cube both sides. Remember to cube it, not square it. So 135 minus 2x equals 5 cubed. 5 times 5 times 5 is 125. All right. Now we just solve for x. Minus 135 minus 135 negative 2x equals 125 minus 135 is a negative 10. Then we just divide by negative 2. Divide by negative 2, x equals 5. And there it is, x equals 5. Easy, easy stuff. I see I'm passing the mark I thought I would get to. You know, I just want to make sure we know it for tomorrow. Okay, now we're getting, so some of the last things we did, we are simplifying this expression. This is easy. We know when we see this, we need to factor that first. Let's have a refresher on factoring. A, B, C, which two numbers multiply to be A times C, which is negative 28, and add up to be B, which is 3. So let's just go through it. 1 and 28, we're not worried about the negative yet. Is that going to get us to 3? No. 2 and 14, no. How about 4 and 7? Yes, 4 and 7 will do it. Now, we look. B is positive, so the smaller number is negative. There's no trick to that. You just got to know. Use your common sense, because 7 minus 4 is a positive 3. If we had flipped them, if we had said 4 and negative 7, that would have got us to negative 3, which is not what B is. So let's rewrite that. We have x minus 4 and x plus 7 over x plus 7. The way we simplify that is easy. This cancels with that, and we're left with x plus 4. That's how we simplify. That's it. This was a pretty good unit. This is rational expressions. All right, this is the stuff you just did your project on too, most of y'all. All right. Moving on. To multiply, we actually don't have to multiply sometimes. We're just going to cancel what can be canceled out. Watch this. X plus 6 and x plus 6. Boom, boom. That's gone. Goodbye. 4x and 4x. That's gone. Goodbye. All we have left is x plus 5 over 3. Guess what? That's our answer. We can't go any further than that. That's it. To divide, we know we flip this second one. So that becomes x minus 3 over x plus 3. So we do not look at this anymore. That's gone. We flip that second one. Now let's get rid of stuff. X minus 3 with this x minus 3, and this x plus 3 with this x plus 3. And we're left with just this, x plus 4 over 5. There's nothing else to do. That's simple, y'all. We were missing that on the test for some reason. I don't know why. That's how easy it is. Just cancel out what you can cancel out. Moving on. Adding when it's a like base is easy. We just add across. 6x plus x plus 3. We see the base is the same, so the base is going to stay the same. 6x minus 12. All right, so 6x plus x is 7x, and then the minus 3. And we're done. All right. For number 23, I'm just going to save us time because we're about to hit the 20-minute mark. Okay, when adding bases with different, when adding expressions with different bases, you just make the bases the same. The easiest way to do that is multiply this one by 5x plus 4, the other base, and multiply this one times the other base, x plus 4. Whatever that base is, you leave it just like that. And then you do it to the top as well, and then just combine them, okay? Moving up here, same thing with subtraction. To solve the equation, remember, you can put it in the calculator, or the easiest way is just to cross multiply and then solve for x. So, cross multiply 8x, because 8 times x equals 5 times 2x minus 6. I just want to show it to you. 5 times 2x is 10x. 5 times negative 6 is minus 30. And that equals 8x. All right. And then you just solve from there. Minus 10x, minus 10x. So we have, I'm moving it up here, negative 2x equals negative 30. Because 8x minus 10x is negative 2x. Divide by negative 2, divide by negative 2, x equals 15. All right, all we did was cross multiply, then solve for x. That's it. All right, almost done. Moving on, let's go to number 28 right here. We just did this one. Okay, select all transformations of the reciprocal function. All right, we see this negative. That tells us reflection over x-axis. Even though there's no parentheses here, we imagine it as parentheses. And anything inside tells a lie. So instead of right 2, we're actually going left 2. We know that. And then finally, that negative 9 on the outside tells the truth. So it's down 9. That's it. All right. Here's where we had that paper and we followed those rules. Go back and look at that rules paper. This time you have to know it. Can't use it on the test. All right, because this is a district assessment. Just go back and review those. All right, but I want to save us time, so we're just going to finish with number 31. The time needed to travel a certain distance varies inversely with the rate of speed. If it takes 8 hours to travel at a certain distance at 36 miles per hour, how long will it take to travel the same distance at 60 miles per hour? So I read it. Now we're going to go back and reread it. We need to find what we're looking for. This is variations. We just did this as well. So the time needed to travel a certain distance varies inversely. We know inverse is y equals k over x. K is our constant. So now we just fill it in. If it takes 8 hours to travel a certain distance, we don't know what k is yet, at 36 miles per hour. All right. How long will it take to travel at 60? We don't worry about 60 yet. We need to solve for k. We're looking at the equation. The way I got that equation, I read it and then I wrote it out. 8 equals k over 36 miles per hour. So let's solve for k. Times 36 times 36. 36 times 8 is 288. So 288 equals k. Now we just fill it in with that new information because it's asking how long will it take to travel the same distance at 60 miles an hour. So y equals 288 over 60. We do that and we get y equals 4.8 hours. And again, I love real world examples because you use common sense. If it took him 8 hours to travel at 36 miles per hour, when he's going 60 miles per hour, should it be shorter or faster time? It should be shorter or longer time. Sorry, getting ahead of myself. It should obviously be, since he's going faster, it should be a shorter time. So 8 hours when he's going 36, 4.8 when he's going 60. Does that make sense? Yes, and we're done. For some reason on the test when we were doing variations, we had one exactly like this. It took him 10 hours at, I think, 20-something miles an hour, and then it said how long would it take him at 50. People were putting 24 hours. How are you going faster, but it takes 24 hours instead of 10? If you're going faster, it should take shorter. All right? Use common sense with those. All right? We're at about 25 minutes. We are done. All right? Make sure you're ready for the district assessment tomorrow.